welcome to a video tutorial working our way through algebra and arithmetic sequences. In this video, I really want to drill down and get into this arithmetic sequence formula. In some previous videos that I've done, we've kind of built our understanding about arithmetic sequences. We have a starting value, the first term A1. We have a common difference that we're repeatedly adding, and it's a number pattern. We're adding the same thing over and over and over to build our arithmetic sequence. Well, we can put this in a formula, and I got it written out here. And what this is saying is, in an arithmetic sequence formula, to find any term, that's what this n means. So n is just kind of unknown. But any term in our sequence can be found, or is equal to, by taking the very first term, adding to it the common difference as many times as you need. And specifically, it's one less than the term you're trying to find. So for example, if you were trying to find the 98th term, you would take the first term and you would add the common difference 97 times because you do one less than the term you're trying to find. But anyways, let's play around with this. A couple examples. One of, here's the first term of the sequence, here's the common difference and how we can write our formula, and then kind of what it means here. So, okay, so the first one, I know based off this information, if I was to write out the sequence, my first term would be -6, and then I'm going to add 0.4 to get the next term. So the next one would be -5.6, next one would be -5.2, and the next one would be -4.8. I know the subtraction and the negative numbers get a little bit weird, but we're adding 0.4, so -6 is less than -4. We're getting bigger. But okay, so that's my sequence. It goes on and on and on. But if I wanted to write a formula for it, I could find any term in the sequence is equal to the first term is -6 plus 0.4, that's what I'm adding, so I'm putting it in place of d, times n minus 1. Now here's how we could use that. So what if I wanted to find the 30th term? Well, I'm going to take -6. I'm going to add a whole bunch of 0.4s. And I'm going to do it one less. So I'm going to multiply the 4.4 by 29. So if I do that out, pull it out of my calculator, 0.4 times 29 is equal to 11.6, but I also have a plus a -6. It ends up equaling the 30th term. If I calculate, do all this math right here, it ends up equaling 5.6. So there you go. So the formula is a helpful way to help you find any term and kind of lets you plug things in, think about things very rationally. All right, let's take a look at this other example over here. So we're told my any term is equal to 25 plus -8. So what this is telling me is my first term had to be 25. That's what the formula is telling me. And the common difference, d, is equal to -8. So I'm subtracting. My sequence is decreasing as I go on. And I would say, okay, so the first few terms are 25 minus 8 would be 17. Minus 8 from that would be 9, 1, and -7, and so forth. All right, so there's my pattern. I'm basing it off on this formula. What if I wanted to find the 100? I like the number 100 today. So what if I wanted to find the 100th term in this sequence? Well, this is telling me to start with 25. We're going to add -8 a whole bunch of times, particularly one less than n. So I'm going to multiply -8 by 99. So let's do that math here. -8 times 99 is -792, but I have the 25 starting value. So the 100th term in this sequence should be -767. All right, there's the arithmetic sequence formula, how to interpret it, how to use it, and just kind of combining everything that we know and have done with sequences up to this point.